A programmable logic controller PLC is a special type of computer that is used to control industrial processes, such as assembly lines, machines, or robots. PLCs are designed to be reliable, flexible, and easy to program and modify. PLCs can perform various functions, such as timing, counting, calculating, comparing, and processing analog signals. PLCs consist of a few basic components, such as 1. A power supply that provides the necessary voltage for the PLC and its modules. 2. A central processing unit CPU that executes the logic program and communicates with other devices. 3. Input and output modules that connect the PLC to sensors and actuators in the field. 4. A backplane or rack that holds the modules and provides electrical and data connections between them. PLCs are programmed using a software tool that allows the user to create a logic diagram using symbols or instructions. The most common programming language for PLCs is ladder logic, which resembles a schematic diagram of relay circuits. Other languages include structured text, function block diagram, instruction list, and sequential function chart. These languages are standardized by the IEC 61131 standard. PLCs are widely used in various industries, such as manufacturing, automotive, chemical, food and beverage, and water treatment, and many more. PLCs offer many advantages over traditional control systems, such as 1. PLCs are more cost-effective and space-saving than a large number of relays and timers. 2. PLCs are more versatile and adaptable to different applications and requirements. 3. PLCs are more user-friendly and easy to maintain and troubleshoot. 4. PLCs are more secure and reliable and can handle harsh environments and faults. PLCs were invented by Dick Morley in 1964. Since then, PLC has revolutionized the industrial and manufacturing sectors. There is a wide range of PLC functions like timing, counting, calculating, comparing, and processing various analog signals. The main advantage of PLC over a hardwired control system is that you can go back and change a PLC after you've programmed it, at little cost, just the cost of the programmer's time. In a hardwired control system, you're essentially having to rip out wires and start from scratch, which is more expensive and takes longer. Let's look at an example to better understand this advantage. Imagine you have a light connected to a switch. In general, the light operates under two conditions, on and off. Now you are given a task that when you turn on the switch, the light should glow only after 30 seconds. With this hardwired setup, we're stuck. The only way to achieve this is to completely rewire our circuit to add a timing relay. That's a lot of hassle for a minor change. This is where a programmable logic controller comes into the picture, which doesn't require any additional wiring and hardware to make sure of a change. Rather, it requires a simple change in code, programming the PLC to only turn on the light 30 seconds after the switch is turned on. So, by using a PLC, it is easy to incorporate multiple inputs and outputs. In all PLC systems, the PLC rack or chassis forms the most important module and acts as the backbone to the system. PLCs are available in different shapes and sizes. When more complex control systems are involved, it requires larger PLC racks. Power supply module is used to provide the required power to the whole PLC system. It converts the available AC power to DC power, which is required by the CPU and input-output module. PLC generally works on a 24V DC supply. Few PLCs use an isolated power supply. CPU module has a central processor, ROM and RAM memory. ROM memory includes an operating system, drivers, and application programs. RAM memory is used to store programs and data. CPU is the brain of PLC with an octal or hexagonal microprocessor. Being a microprocessor-based CPU, it replaces timers, relays, and counters. Two types of processors, a single bit or word processor, can be incorporated with a PLC. 1-bit processor is used to perform logic functions. Word processors are used for processing text, numerical data, controlling and recording data. Input and output module. Have you ever thought about how to sense physical parameters like temperature, pressure, flow, etc.? PLC has an exclusive module for interfacing inputs and output, which is called an input and output module. Input devices can be either start and stop push buttons, switches, etc., and output devices can be electric heater, valves, relays, etc. Input-output module helps to interface input and output devices with a microprocessor. Let's discuss the types of PLCs. The two main types of PLC, which are fixed compact PLC and modular PLC. Compact PLC, within a single case, there would be many modules. It has a fixed number of input-output modules and external input-output cards. So, it does not have the capability to expand the modules. Every input and output would be decided by the manufacturer. Modular PLC. This type of PLC permits multiple expansions through modules, hence referred to as modular PLC. Input-output components can be increased. It is easier to use because each component is independent of each other. PLCs are divided into three types based on output, namely relay output, transistor output, and triac output PLC. The relay output type is best suited for both AC and DC output devices. Transistor output type PLC uses switching operations and is used inside microprocessors. According to the physical size, a PLC is divided into mini, micro, and nano PLC. Some of the manufacturers of PLCs include Allen Bradley, AB, Siemens, Mitsubishi PLC, Hitachi PLC, Delta PLC, General Electric GE PLC, Honeywell PLC. PLC applications. PLCs have a variety of applications and uses, including 1. Process automation plants, e.g. mining, oil and gas. 2. Glass industry. 3. Paper industry. 4. Cement manufacturing. 5. In boilers, thermal power plants. 6. Power station applications. PLCs play a crucial role in power stations and smart grid systems. They are used in smart grid systems to monitor and detect fault conditions, power generation, transmission, and distribution systems, power substations, auto assembly line systems.